Welcome back. We're going to talk now about angles in radians. Now, I told you a minute ago that radians are just another way of measuring how far around a circle we have rotated. And we're going to get to that. Before we talk about radians, though, I need to talk to you about the notion of arc length. An arc length is really a measure of how far we have walked along the perimeter of our circle. So this measure S is the arc length. And this angle theta is the angle that subtends that arc length. And of course, we've got a circle of radius r. Now, if we go all the way around the circle, we're talking about the circumference. The circumference means really we walked all the way around the outside of our circle once. And you'll remember from earlier work that circumference of a circle is 2 pi r. Okay? Regardless of the size of the circle, we can always calculate the circumference from this formula. So let's take a look at two circles. One has radius 2 and the other has radius 3. And let's say we walk along the edge of those circles until we meet the line that marked a 45-degree rotation. In either case, we've gone 1/8 of the way around the circle, right? So 45 degrees equals 1/8 of a rotation. So that means then that in each case, I have moved 1/8 of my circumference. Yes? So we can figure the arc length of either of these marks. So let's figure the outer one. S equals 1/8 of my circumference. Or we usually write that as pi over 4 times r. So let's look at my smaller one. So let's call this guy S1. Let's call this guy S2. S2, well, okay, so notice I don't have my radius in there. So my radius is just a variable at this point. So for my big one, I replaced my radius with 3, and my arc length would be 3 pi over 4. For my little one, or my arc length. For my little one, my littler circle, I would replace the radius with 2, and my arc length would be 2 pi over 4, or 1/2 pi. And really, we've gotten to where we're beginning to talk about radians. So here's the bottom line for radians. A radian measure of rotation or of an angle is the ratio of the length of the circular arc, in other words, the arc length, that results when you rotate that measure of angle around the circle, in other words, subtended by the angle, to the radius of the circle. In other words, the radian measure equals S over R. So what does that mean? Well, the thing you need to note is that this ratio between S1 and the radius 2 is the same as the ratio between this larger arc length and its radius 3. That ratio is the same, and that ratio is the radian measure of 45 degrees. So one rotation is 360 degrees, or 2 pi radians. 1/2 of a rotation is 180 degrees, or pi radians. 1/4 of a rotation is 90 degrees, or pi over 2 radians. Now, these are just numbers. The 2 pi, the pi, and the pi over 2 are just numbers. But we want to use exact numbers, so we're going to keep the pi in our radian measure and not replace it with a numerical approximation. So it was helpful to be able to go back and forth between radians and degrees, and here it is. So 1 degree is equal to pi over 180 radians, and 1 radian is equal to 180 over pi degrees. So suppose I want to convert pi over 6 to degrees. I have radians, I want degrees. So I will multiply by 180 degrees over pi, and I get 30 degrees. Suppose I want to convert 15 degrees to radians. I've got degrees, I want radians, so I will multiply by pi over 180 degrees. And I get pi over 12. All right, and that now brings us to the point where we can talk about our unit circle in radians. So just as we had a unit circle that depicted our special known angles in degrees, we can depict those same angles in radians. And frequently you will encounter the unit circle with both degrees and radians marked on it, and that is how it is shown in your trig cheat sheet that you'll find in the Canvas shell. So this is our unit circle with our special known angles on it. And just to help you out, this is equivalent to 30 degrees. This is 45 degrees, 60 degrees, 90, 120, and so on all the way around. What that means is we rotate from the positive x-axis 120 degrees to get to that line, which also takes us to that point on the circle. Okay. This is going to become, like I said, more important as we move through the course, and we will keep adding to this unit circle. And we'll talk about it more as we get to that point. I'm going to stop this video here, and I'll come back in a separate video and talk about arc length and the area of a sector of a circle. So I'll talk to you again soon.